to the Truth in My Days podcast, where we defend the Word of God against the challenges of men.
Hi, I'm Dana Torse, and welcome to another episode of the Truth in My Days radio program. Today, I'm here with John Torse and Jason Chan as they discuss the important topic of creation and evolution. We are continuing from the previous episode. We hope you enjoy.
Sorry, before we continue, why would we expect a random distribution of galaxies?
Because the original Big Bang, all of the matter energy is inside this tiny little singularity, which then suddenly expands. Mm-hmm. And so matter is thrown out in all directions randomly. Mm-hmm. There's no pattern to it.
Right.
So the chance of having accretion at any point is just randomly distributed.
Right, okay.
So you should have that random distribution, but that's not what they found. And it led to a crisis internally, a crisis in 1986. Okay? Dwayne Gish of the ICR does a good write-up on this. And as he tells us, a fellow called Tully from the University of Hawaii demonstrated that there were ribbons of superclusters of galaxies 300 million light years long and 100 million light years thick, stretching out about 1 billion light years and separated by voids about 300 million light years across. Now, again, light years is a measure of distance, not time. But it's basically what you have is this pattern in the universe that looks almost like concentric circle or spheres, where you get lots of galaxies and then a void between them with very little, and then another big. It's anything but random. And as Tully explains, these structures are much too big for the Big Bang Theory to produce. At the speeds at which these galaxies are supposed to be moving, it will require 80 billion years to create such a huge complex. Oh. But they tell us the age of the universe is like 13.6 billion.
Right.
Where did these come from then? And it got worse. In 1989, two scientists, Margaret Geller and John Huchra from the Harvard-Smithsonian Center for Astrophysics, announced the results of their research. Their map of the sky showed a structure they called the Great Wall, a huge sheet of galaxies 200 million light years across, 700 million light years long. Another team, the American, British, and Hungarian astronomers, discovered even larger structures. Again, the galaxies in thin bands with about 600 million light years of void, rough void between them. And this pattern then stretched across about a quarter of the diameter of the entire universe. And they would say, according to the Big Bang model, this kind of shell and void pattern would take nearly 150 billion years to form. And again, they tell us the universe is 13.6 billion. So what do you do with that? And let me remind you, this is not something the general public knows. This is not something that most of those Christians who use the Big Bang Theory as an apologetic and are happy to bend Genesis to fit, they have no idea about this. So what do? Well, they try fudge factors. They invent hypotheses to explain why their hypotheses didn't work. Dark matter, you might have heard of that. Mm-hmm. Cold dark matter. You need more gravitational pull to make these happen, so you need more matter. It's not there, so we'll just say, well, okay, it's not there, our theory must be wrong. No, you say it's there. We just can't see it. We can't touch it. We can't interact with it, but it's there. 90 to 99% of all the matter in the universe is actually dark and you can't detect it. But it's there, otherwise our theory is wrong. And they're hoping that this cold, dark matter would explain the problem. But it really doesn't. Because after they proposed that, you have more work on the discoveries of the structures and their size. And they turn out to be so massive that even if you put in this cold, dark matter, it still wouldn't explain the formation. So Saunders and the co-workers published in Nature, top scientific journal, they said that, look, the cold, dark matter model can be ruled out to at least the 97% confidence level. And it kept getting worse. In 1991, the joint US-European Röntgen satellite, ROSAT, discovered that there are giant superclusters of quasars on the very edge of the universe, supposedly 8 to 12 billion light years from Earth. And so even if there were was cold dark matter. It wouldn't explain the existence of these giant clusters of quasars, and yet they're there. Yeah, so here's the thing. There are insurmountable problems with the Big Bang Theory. If it weren't necessary to have an excuse to get rid of God, it would have been tossed ages ago. It's kept because you need something to try to explain origins without God. Now, another dodge they had then was this inflationary model. They said that once you have this initial expansion of this singularity, you went through a period of massive inflation. The expanding ball of matter energy suddenly stretched out with dramatic speed. And so before that, the part of the universe we could observe was so small that density fluctuations, you can't possibly find them. You can only describe them by probabilities. But then when the inflation began, these existing fluctuations were inflated to great size and became the fluctuations in the cosmic background radiation and the seed of large-scale structures in the universe. But as we said, as we've seen, it doesn't explain it. It's just not enough. It doesn't solve the problem it was invented to solve. Those fluctuations are not enough. Furthermore, inflation requires a density 20 times larger than what's implied by their model of nucleosynthesis. And we'll get to that when we look at that line of argument. There's no explanation. They can't explain why it would have happened. But it had to have, to keep our theory viable. It had to have happened. They have no explanation for it. And of course, there's no way to observe it or test it. So it's not science. It's out of the realm of science. And then, of course, during that, as we've mentioned before, during that inflation period, light is moving much, much faster than the speed of light. So this is your cosmic background radiation argument number one. It just does not do what it's supposed to do. The second line of argument was that the universe is expanding. Now, the idea is that the galaxies outside of the Milky Way, the galaxy we live in, are moving away from us at a rate proportional to their distance from us, which suggests that the universe is continually expanding from a single source. Immediately, do you see a problem with that? Even if the universe were expanding, does that mean it started from an original singularity?
Not necessarily.
Yeah, exactly. God could have built a universe with galaxies certain distance apart from each other initially, and then, as part of the natural world, started them moving. Right? That's very, very possible. Second thing is, how do we know they're moving away from us? How do we know? Well, the redshift. You know what redshift is, right?
Does this have to do with the Doppler effect?
Yes, exactly. Can you explain for our listeners what the redshift is?
Basically, when something is moving away from us, the frequency that its waves hit us is decreased. So think about a car moving towards you. When it's coming towards you, the pitch of the car is high, but then as it zooms past you and goes behind you, the sound of the car becomes lower. So this happens with sound waves, and this also happens with light waves as well. So the redshift is for something that gets farther and farther away from you.
Mm-hmm. Why is it called redshift?
Because the frequency of red light waves is lower than the frequency of blue waves, for example.
Yeah, so if you're coming towards you, what kind of shift would you see?
If it were coming towards you, you should see a blue shift.
Exactly. So an object that's giving off light waves, it's like, imagine if you have a pond of water. It's still a pond and you drop a rock into it. What do you see? You see these waves from where you disturb the water coming out from the point where you drop the rock, and they're moving away. And they're concentric circles, and the distance between them is the same on all sides. Mm-hmm. If you have a motorboat, though, for example, moving through the water, okay, it's doing the same thing. But as the motorboat moves, it's squeezing together the wavefronts in front of it.
Right.
And the wavefronts behind it get stretched out. Mm-hmm. So the wavelength gets longer. So you see light, and you're expecting to see a certain spectrum of colors in it. And you see that it's not what you expected. It's the light is moved more towards the longer wavelengths, more to the red end of the spectrum. I asked, why is it? Well, maybe it's like a motorboat. Maybe this object giving off the light is moving away from us. And so the waves in front of it, the light waves, are squeezed together, and the light waves behind it are stretched out into the red end of the spectrum. That's called red shifting. Mm-hmm. And we look at these galaxies around us, and we see a red shift in them. And then we think, well, this is why. And that's actually where the Big Bang started from. This was the first thing that started this observation that the universe seems to be expanding. But there's a couple of problems with that. If this is the explanation from the redshift, then the amount of the redshift would depend on the distance it is away from us. It shouldn't depend on the type of galaxy. You should have a random distribution of redshifts. But that's not what we found. An astronomer named Tift found in the 1970s that the redshift depends on the type of galaxy. Spiral galaxies, for example, had a higher redshift than elliptical galaxies. So that's a problem. How do you explain that? If the redshift is caused by things moving away from us, it should be the same regardless of the type of galaxy, but that's not what we found. Yeah. Then he found another startling discovery. Again, if the Big Bang happened, then the galaxies should be randomly distributed throughout the universe. All the galaxies should be randomly separated from us. So if we looked at the values of the red shifts, they should be randomly distributed. Mm-hmm. But they aren't. Redshifts appear to increase by quantum leaps, specifically by a leap of 45 miles per second. So they're quantized. Actually, they're not randomly distributed. So this a couple of issues that bring into question whether, in fact, this is the explanation at all for why these things are redshifted.
Thank you, everyone, for listening today. Unfortunately, we have run out of time, but please join us for the next part tomorrow. Same time and same place. If you enjoy our content and think this is important material, the best compliment you can pay is by sharing this with your friends and family. This helps us out a lot. Also, if you enjoyed today's program, please like, comment, share, and subscribe to this podcast. We would love to hear from you. Thank you for listening to the Truth in My Days podcast with John Torse. We would love to hear from you. Please feel free to share any questions or comments you may have. You can reach us on Facebook, Instagram, MeWe, and YouTube. Simply search Truth in My Days as one word. Again, Truth in My Days as one word, no spaces in between. And you can connect with us. You may also visit our website for more comprehensive material and to learn more about our ministry. Our website is truthinmydays.com. Thank you.